Hello guys, this is Prime Concept. We want to consider a topic, logarithm. So we'll be analyzing the concept of logarithm, be looking at the rules or the laws of logarithm, be seeing how logarithm is related to indices and how these two concepts can help us in our study of calculus. So do well to stick with me in this video till the end, and we'll be solving problems that would open your eyes to the concept of logarithm. Meanwhile, if you have been watching my videos and you are yet to subscribe, please do well to hit the subscribe button, like this video, and comment. Right, let's go into the video. Now, what is logarithm? First, we want to establish that logarithm is actually the inverse of exponents, or the inverse of indices, what we know as indices, which is actually an exponential function. So logarithm is the inverse of indices. That is one thing we want to know before we get into the definition. So log is the inverse of exponential function. Exponential function, which you know as indices. So logarithm is the inverse of this. And then how do we define logarithm? A simple way to define logarithm is that logarithm of a number is the exponent of a fixed number, which is the base of the logarithm. The logarithm of a number, say x, is the exponent of a fixed number, which is the base of the logarithm. So let me write it, then I will explain further. So by definition, we can say that the logarithm of a number, say x, is the base, is the exponent of a fixed number, which is the base of the log, which is the base. That is to say, by definition, the mathematical definition is log of x to base a is equal to y if and only if x is equal to a to power y. So you quickly see this is the mathematical definition of logarithm, which simply says that the log of a number x would be equal to y. We said the logarithm of a number is y, which is actually the exponent. You can see this is the exponent or power of the base of that logarithm. So that is it by definition. So the logarithm is the power or the exponent of a fixed number, and that fixed number is the base of the logarithm. So this, in our later, subsequently, we're going to prove this, but this is actually the definition for logarithm. So I believe this is very clear to you. Now, quickly, want to point out that we have two kinds of logarithm. But first of all, when you have something like this is how we denote logarithm, like this. Log, we say log x, and we say this. In this case, this is the number we're trying to find the logarithm. So you're trying to find the logarithm. This is the number that you are interested in getting the logarithm of, right? It could be 2, 3, 1, 4, any number, 0.4, and so on. So you're trying to find the logarithm of this number, while this one is what you know as the base of the logarithm, is fixed, is a constant, which is the base of the logarithm. So this is how we denote logarithm. And it is very important for us to know that we have, say, two types of logarithm. So we have two types of log, right? Now, number one is what we know, which I would call common logarithm. Number one is common logarithm. When you say common logarithm, this is where you would always be seeing the symbol log, log. You'll be seeing this. This is what we know as common or general logarithm. So this is common or general logarithm. So you can have something like, you see, log 2 to base 3, log 4 to base 5, and so on. So this is a common logarithm with the symbol log, while this is always going to be a number. It can be any number, 2, 3, 1, 4, and so on. It's going to be a number, right? Yes, then we have the second type of logarithm. The second is what we actually know as natural logarithm. Natural logarithm. Natural logarithm. And natural logarithm is denoted with the symbol lim. You would see this in your calculator, lim. So you'd have something like, say, lim x. Another way of denoting the natural logarithm, you don't want to use lim. This is pronounced as lim. You don't want to use lim. You can use the symbol log x to base e. So this natural logarithm would always be described with the base e, while our common logarithm can have any base, any number as the base. But for your natural, the base is always what? E. So these are the two types. But what is special about this is that the rules of logarithm that applies to common logarithm also applies to what? The natural logarithm. So we don't have to learn rules for common logarithm or general and then learn for the natural. The same rule applies, right? So you don't have to worry. So very quickly, we want to get into the rules of logarithm. Logarithm is actually just like an exponential function or the indices. Logarithm is dependent on rules. If the rules are clear to you, then you can solve any problem. So I'll be giving the rules of logarithm in detail such that any problem can be handled. Now, number one rule I want to mention is the log of 1 to base a. So if you have log 1 to any base, a can be anything. A can be 2. Of course, we're considering positive values. A greater than 0. That's the a can be 1, 2, 3, 4, and so on. So when you have log of 1 to that base, it would always equate to what? 0. So it would always give us the result 0. So you don't have to worry about this. Say, for example, you have log 1 to base 4. What would this be? Without solving, the answer is what? 0. As long as this is 1 to any base, it becomes 0, right? Yes, so this is a very important rule. Rule 2, and we can actually prove this. So let me do a quick proof on this, and this follows from exponential function or the indices. And if you recall, in indices, we said that a to power 0 is actually equal to what? To 1. Anything to power 0 is equal to 1, right? Yes. Now, if this is true, what I'm going to do, I'm going to take log to base a of both sides of this particular equation. So I'll have log a to power 0 to base a. I'm taking log to base a. So I'll do the same thing here. Log 1 to base a, right? Yes. Now this 0 from one of the laws which I've not mentioned, but then in the course of the video you still learn it. So this 0, when it comes behind, you have 0 times log a to base a, which is equal to log 1 to base a, right? Now you know that when 0 multiplies anything, what would the result be? It would be 0, so which is equal to log 1 to base a. So which is what we have said, that log 1 to base a will give us 0. So I believe this is clear to us. So now let's look at the second rule. Second rule or law of logarithm, because we are not following these laws necessarily sequentially. So when we say second, does not mean it must be the second. So, but the next one, which is number 2, is log of a to base a. This would give us the result 1. That is to say, whenever you have log of a number to the same number, this would be 1. For example, say we have log 2 base 2. This would give us what? 1, right? Yeah, because these two numbers are the same. You have log 3 to base 3 to still give us 1. But the exam may not come this direct for you. So they will give you problems that would require you to do some solving, right? So I will not do that now because of some laws I've not mentioned. So, but for now, you should know log of a number to the same base would give us 1. So let's look at the number 3. Number 3, if you have log x times y to base a, say you have this, you have two numbers multiplying. This dot means multiplication. So I have two numbers multiplying, x times y, and they have a common base. So according to this law, this can be written as log x to base a plus this multiplication will now become addition, and you separate them, log y to base a. So this can be written in this form, right? Yes. Now, and it's very simple. Let me give you an example that would also help us digest this. Now let's say you have log, say you have log 6 to base 3. Let's say we have this. Now one of the things you notice is that if I want to simplify this, or let's say I want to just expand this just to apply or show this law, this can be written as log to base 3 of, now 6 can be split into 2 times 3, right? Yes, so that by this law I can split this. So I would have log 2 base 3 plus log 3, which is this one, base 3. Notice I'm taking their common base. So this is going to give me log 2 base 3 plus what now? You are very correct. Log 3 to base 3, what will it give us? 1. So you see that we have moved this from this point to this point. And one beautiful thing about this law is that a question may require you to move from this point to this point, or from this point to this point. So whichever one is required, you apply the law. Now let's look at law 4. All right, so we want to consider rule 4, on the fourth rule. So I believe that this one is clear to us. Now, number 4, at the end we'll be putting all these rules together and see how we can apply them to solving more complex problems, which I would simplify in such a way that it will be very clear to you. Now, rule 4, you have log of, let's say, x divided by y. Now, this has a base of a. And when you have division like this, this would be equal to log of x to base a. You can split it, but because it is division, you split by subtraction. So, and you're starting with the one above. It has to be log x first. So log, then log y to the same base a. So this is also true. You split. Don't start with log y. Now you should also note that this, you should note that log x over y to base a, this is not the same. This is not equal to log x base a all over log y base a. These are not equal. So please don't make this mistake. This is not true. This is not the rule. So this is the rule. You have x divided by y before you take the log. So this is not true. Don't make this mistake. In the same way, don't make the mistake of, don't also make the mistake of saying that log x times y to base a. Don't make the mistake. This is not equal to log x to base a times log y to base a. These two things are not also the same. So please do well to take note of these 2 points. Don't make this mistake. Now let's look at an important application of this rule number 4. See how we can use it. Now rule number 4, say we have, let's say I have log, say I have log 2 log, let's say log 8 base 2 minus log 2 log 4 base 2. Let's say I have something like this to simplify. Very importantly, you would first notice that before you can apply this law, their bases must be what? Common or the same. So this base is base 2, this is also base 2, common base. Then I can apply the subtraction. The subtraction would lead me to what? Division. So if I should solve this, I can say log, then I would start with the first, which is 8. So I would say 8 divided by the next, which is what? 4. Then what is the common base? 2. So this is equal to log. Now 8 divided by 4 is going to give me 2. So I have log 2 to base 2, right? Now do I leave my answer this way? Of course not. So what do you think would be the final answer? The final answer, because I have 2 and I have 2, my final answer will become what? 1, because log 2 to the same base 2 would be equal to 1. So you see how we have simplified this, and the answer is actually what? 1. So that is how you can use this. You can move from here to here, here to here, depending on what you want to achieve in the question. So let's quickly go to law or rule number 5. This one is what we know as power law. Power law. So the power law is very important, too important. Now, what does it say? If you have log, let's say x to the base a now, and this x is carrying a power n, where n can be any number, 1, 2, 3, 4, and so on, even negative numbers. Now, if you have this, even fractional numbers, so if you have this would equate to n log x base a. That is to say, you can use the power to multiply the log, right? So this power law is very important law. So an example would be, say I want to simplify log 8 base 2. So I want to simplify this. What do you think I'm going to do? First, I would notice that 8 can be written in terms of 2, right? As an exponent, right? Yes, so I can write this. This would become log, instead of 8, I would say 2 to power 3, which is same thing as 8. Then base what now? Base 2. Now, applying my power law here, what do you think would happen? This 3 would come and multiply, come to the back. So it becomes 3 log 2 base 2. Now, you know that log 2 base 2 is what? 1. So 1 times 3 becomes what? 3. So this is an important application of the power law. So that is law or rule number 5. So very quickly, we want to consider rule number 6. Number 6, which is what I call change of base. Say we have some base, like we are dealing with base A, but we want to get a new base. So from, let's say, from base A to base B. So we want to change from base A to a new base B because of what we want to achieve. Now we have log x base A, and I want to change this from base A to base B. This would be the same as saying log x to my new base B, all divided by log my old base now, which is A, to the new base B. So this is what we know as the change of base. So it will be necessary for me to prove this. So I'm going to prove this very quickly now. Say we want to show that this is true. Now I have log x to base A, right? I want to change this. So let me just equate this to some random variable y. Now quickly, you would notice that I can write this as log x to base A, which is equal to y log A base A, right? Yes, now why is this true? That is true because log A to base A is 1. 1 times y is still going to give me back y. So have I changed anything there? Of course not, I have not. So I can write this as log x base A, which is this, equal to, if I come to this side, I'll quickly apply the power law. So this y would come above. So I'll have log A to base A, then this to power y. So that since these bases are common, of course, if I move to this side, I can use the subtraction, but let me just see that this can go, right? Yeah, so if this should go, I'll be left with x, which is equal to A to power what? Y. Now I want to achieve a new base. And what is the new base I want to achieve? Base B. So I'm going to take log to both sides of base what now? Base B. So I'll have log x to base B, which is what I need, would be equal to log a to power y base what? B. So I have log x base B equal to, now power law, this y would come behind. So I have y log a base B. Now I want to make y the subject. So if I make y the subject, I would simply have that y is equal to log x base B divided by what now? Log a base B. This is what I would have. But what is our y? You've noticed that y is this. So I can write that y, which is log x base A, which is y, is now equal to log x base B divided by log what now? A base B. So we've been able to show or prove that the change of base rule is true. So it's very simple. So I'm going to give a simple application or use of this that will help us understand it. Now say I want to change from base 3 to base 2, right? And I have log of 5 base 3. Or let's say log of 4 base 3. So I want to change from base 3 now to a new base 2. So do well, pause this video and solve this. Drop the answer in the comment section. Let's check. Now let's do it together. So this is going to be log, I'll start with this, log 4 to my new base, base 2, divided by log of my previous base, which is 3 now, to the new base of 2. Right? Now, if I solve this, this would give me, now I know I can still simplify this further, right? Because I know that 4 is same as 2 raised to power 2. So I would have log of 2 raised to power 2, which is for 4 there, base 2, divided by log of 3 base 2, right? Now, if I apply power law here, this 2 would come behind. So I would have 2 log of 2 base 2 divided by log 3 base 2. Now you know that log 2 base 2 is what? Is 1. So 1 times 2 is 2. So my final answer for that would now be, it would now be 2, which is what I'm left with there, over log 3 base 2. So this is what my final answer would be. So this is how you can apply the change of base, So I believe it's clear. And let's look at number 7 rule. Number 7, say I have log x base A raised to power n. And you notice that this time around, my power is with the base. So if I have this, very quickly, this would now become 1 over n log x base A. So this is what I would have here, which we can also prove this. It's still very simple. Now let's quickly prove it so it will be clear to us. I want to show that this law is true. So I have log x base A raised to power n. Let me call this, I don't know what it will be yet. So let's call it y. Now if this is the case, I can have that this would become x. I want to go straight. X would actually be A raised to power n y, right? Yes. So very quickly, I'm going to take log of both sides. I'm going to take log to base A of both sides because I want to achieve base A. So I have log x to base A equal to log A to power ny base A. So I have log x base A equal to power law. I would have ny log A base A. So what do you think would happen there? Very quickly, you are seeing already that log a to base a there is what? Is 1. So I would be left with, so I have this. So I have log x base a equal to what? Now I'll be left with ny because log a base a is 1. So if I make y the subject, because I'm trying to find y, remember I said let this whole thing be y. So what is y going to be? If I make y the subject, y would now become, I'm dividing by n. So I have 1 by n log x base a. So what is our y? We said that y is this. So I can write it that log x base a to power n, which is y, is equal to 1 divided by n log x base a. So this is what we were trying to prove, and we have arrived at it. So it means that rule 7 is true, right? So I believe this is clear. Now quickly, let's look at rule 8. Rule 8 is what we have been using actually. Rule 8 says that if log x base a is equal to y, this would imply that x would be equal to a raised to power y. So we stated this as the definition of logarithm, but we want to also prove this. At this point, we want to prove that. So if log x to base a is equal to y, then it means that for you to make y the subject, and for you to make x the subject, x will become a to power y. So you're just using this base to raise this up. So if this is true, let's quickly show that it is true. So I have that log x to base a equal to y. Now quickly, I can attach to this, I can attach log a base a, and I wouldn't have changed anything because log a base a is 1. 1 times y is y, and I still have that. So if I apply power law, I would have log x base a equal to log a to power y, because this will become a power base a. So quickly, I can say this would go, and if that happens, I'll be left with x on this side, which is equal to a to power y. So this is what I'm trying to show, right? Yes, yes. So this is a rule also, which is actually the definition for our logarithm. Now let me give you a quick application here. Say we have e.g. log 2 base x. Okay, let me say log 4 base x. Let's say this is equal to 2, find x. So you have this question on the exam and you are required to find x. So very quickly, without going through this process, I know that 4, I would make 4 the subject. So I would have 4, and this would be x is coming to raise this up. So I'll have x to power 2, right? Or I can just say x squared equals 4. So that x would now become the square root of 4. And what is the square root of 4? 2, right? Yes, plus or minus 2, but then we're taking the positive value 2. So this is how you can apply rule 8 to solving problems like this. Now, so let's look at the final one I want to mention, the final rule, which is rule 9. Rule 9, so we have a to power log of x base a. So we have this. What would this be equal to? This would be equal to x, right? Now, if you notice, when you have a base and it's same as the base of your logarithm, then it will just be what you have here, which is x. And we can prove this. It's very simple. So to prove this, let's say that log x to base a, let's say it is equal to y. So that if I want to make x the subject, I will just say that x becomes a to power y, right? And what is y actually? Y is this. So it means that x is equal to a to power my y, which is log x base a. So can you see that this is true? So our answer, when you have a to power log of x to base a, this would still give us x, right? So no matter how complex it looks, this is just it. So this is rule 9. So do well to take note of that rule. So quickly now, since we have been able to outline all the rules, we're going to take about 3 problems in this video, and then subsequently we'll begin to solve problems separately outside this video. So let's take our first example. All right, now we'll have these 3 problems. We're going to solve them in this video, and next video we'll solve more examples, so do well to follow me. Now the first one says, if log y to base x is equal to minus 2, so this is a condition. So if log y to base x is minus 2, find log y to base x squared, right? So you notice that our base is carrying a power. So quickly, this is what I'm required to find. Log y to base x squared. I'm required to find this, evaluate this. What would the result be? So quickly, since my base is carrying a power, I know that this should be equal to 1 divided by that power, which is 2, then log y to base x without a power. So I have 1 over 2. Now they told us that log y to base x is minus 2. So log y to base x is minus 2. So I'll replace that with minus 2. So if I solve this, this would fizzle this, right? 2 into 2 is 1. Minus 1 times this. So my answer is minus 1. So that is it. Now I want to solve the second one. The second part of number 1 says we should evaluate log y to base root x. Now one of the things you know is that square roots can be written as 1 power 1 over 2. So I can write this to be log y base x to power 1 over 2 instead of the square root. Now still the same rule that applies here. So I would write this. This becomes 1 divided by my power. What is my power? 1 over 2. So 1 divided by 1 over 2. That is the rule I'm applying. Then log y to base x without a power. And 1 divided by 1 over 2 simply means you just take 2 up. So this will just be 2 log y base x, right? Now we have to already know that log y base x is minus 2 from the question. So I will now multiply by minus 2. So if you multiply this, 2 times minus 2 gives us minus 4. And this is the answer. So we have solved number 1. And I believe it's very simple and very clear. Now I want to look at question number 2. Question number 2. So I'll be rubbing this. Now question number 2 says we want to evaluate or simplify log 7 to base 49 minus log 64 to base 8. Now you notice that their bases are no longer the same, and there's nothing you can do to make this base common, right? So you don't think about making the bases common. So first, you notice that there's a relationship between 7 and 49. There's a relationship between 64 and 8. So what is that relationship? 49 can be written as 7 to power 2, while 64 can be written as 8 to power 2. So I'm going to use that. So I have log 7 base, instead of 49, I have 7 to power 2 minus log, instead of 64, I have 8 to power 2. Then base what now? Base 8. So applying what we have known, when our base has a power, it would come to the back as 1 over that power. So what do I have here? So I'll write 1 divided by my power, which is 2, then log 7 base 7 minus, when this is having the power, now it will just multiply. So I have 2 log 8 base 8, right? Yes. Now you know that log of a number to the same base will give us 1. So I just have half times 1, right? Minus 2 times 1. So if I solve this, what will it give me? Very simple. I would have that half times 1. Half times 1 is half minus 2. 2 times 1 is 2. So what will I do? I'll just say 2 multiplied by this 2 is 4. So I have 1 minus 4 is minus 3 over 2. So my answer to this question is minus 3 over 2. So I believe it's also very clear. Then finally, want to look at question number 3. So without a soothsayer, you would see that this might lead us to quadratic because of the power of x. So let me rub this, and then we'll solve that finally and call it an end for this video. So we have, do well to attempt this, drop your answer before you finish up the video, pause it, attempt this, then drop the answer. So I have this. First thing I want to do is to know that this base, I can use it to raise this power up, and by the moment I do that, logarithm will disappear, right? So I will be left with x squared minus 8x equal to, this 3 is coming to raise this, equal to 3 to the power 2. So I have x squared minus 8x equal to 9. When I bring this to this side, I have x squared minus 8x minus 9 equals 0. This is now a quadratic. Now for quadratic factorization, this is what I'll do, since my coefficient of x squared is 1. So this is what I'll just do. Now I'm going to search for two numbers, or think of two numbers, such that when I multiply those two numbers, I will get minus 9. When I add those two numbers, I will get minus 8. Two numbers that when you multiply, you get minus 9. When you add, you get minus 8. So what could those two numbers be? So I can say 8. Okay, I can say 9 times 1 is actually 9. So those two numbers could be 9 and 1. This could be the two numbers, so that when I say this times this, it will give me 9, but I need minus 9. So I can say minus 9 and then plus 1. So that when I say minus 9 times 1, it will give me minus 9. When I say minus 9 plus 1, it will give me minus 8. So those are the two numbers. I'll quickly insert them here. Minus 9, and then I'll say plus 1. Or I can still say plus 1 and then minus 9. Same thing. So quickly, I have that x minus 9 is 0, or x plus 1 is what? 0. So that I would say that x, when I move this, is 9, or x, when I move this, is what? Minus 1. So these are the values of x from this particular problem. So I believe that if you have watched this video from the start to this point, the concept, the whole concept of logarithm would be very clear to you without missing anything. So do well to subscribe to my channel. If you are yet to subscribe, this is your own way of showing me that you love what I'm doing and you're supporting what I'm doing. So like this video, comment, then share with 10 of your friends. Tell them this is Prime Concept. I'll see you in the next video.